That looks like the right one. Good morning. Very happy to be back here with you. I believe the last time that I was here was about 4 or 5 months back when we started to survey the onshore and nearshore area here, and I get to show you some of the results. Not all of them. Actually, this Wednesday will be the completion of it, but I get to show you some of the early findings, and it's very exciting. So first of all, just a little bit about the project. We went to the air and we gathered as much information as we could from the air using different sorts of sensors, magnetic sensors, gravity sensors, hyperspectral sensors, etc. And we scanned all of these at the same time, and basically we're able to gather extremely good high-resolution data. Those then, we worked very hard on applying some new technologies, and we have lots of interpretation results. I'm going to be showing some of those to you now. First, a little bit about the methodology that we use. So NEOS was formed to be able to attack large amounts of data all at the same time. And it's very similar to a lot of the data mining things that you see going on now in the marketing world and the insurance world, etc., where you've got massive compute power now that allows you to look at all this data at the same time. And that's what we do. So we go out and we gather as much of cost-effective, low environmental footprint sort of data that we can. We then take everything that we can find, things from the universities, any of the seismic data, well data, and we integrate those all into a fused Earth model of what's going on. On top of that, we've built algorithms that allow us to look for patterns. So in the case that you'll be seeing here, we've looked around the region. And one of the good news, and one of the things that we always think about in oil and gas exploration, is the best place to find oil and gas is where you have oil and gas. And we're very lucky here. So we've applied these different methodologies, and now I'm going to walk through some of the results of that. First of all, a little bit about the measurements themselves. So what about gravity? What does it actually tell you? Well, it actually gives you insights into lots of different things, including the density of the rocks, the organization of the structure. You couple that with the magnetic readings, which also give you information about what sort of magnetic rocks might have intruded. That helps you understand not only the structure, but also the thermal history, how cooked is the oil, how cooked is the gas, etc. You couple that with information from EM, which actually gives you an idea of what's actually going on in the pore space. And that allows you, we actually measure the ability of current to flow. And that allows you to really understand and understand exactly what might be out deep beneath the surface. You also add something that's quite unique here. We added hyperspectral. And what that is that's basically flying over the land, measuring the reflectance of lots of different parts of the electromagnetic spectrum. What this gives you is a very good idea is what's at the surface area. And we can match that up almost like a fingerprint. And so we're able to see things that are happening, including, very important here, hydrocarbon seeps, and the indication that seeps might have been there in the past. So all of these are clues to the big puzzle of what's going on. So we use this information to integrate from the very top to the very, very deep. And we can get lots of insights into what might be going on in terms of what's happening at the surface, the near surface, the reservoir, and at the basement. And all of those contribute to a holistic view of what is going on. So here's some of the results. You can see the magnetic data gives you a very strong indication of different regions of structure, as does the gravity data. It understands basins. I can't exactly let you know what the MT is because it just looks like a bunch of wiggles, but those wiggles can be interpreted and inverted in 3D, which I'll show you soon, that shows what's going on at depth. So those different data layers also give us an idea of what's going on. Where are the depositional centers? Where would we find the hydrocarbons pooled? As well as what sort of intrusions have happened that might cook them in a differential way. All of this helps us understand everything that's going on at the basement as you move your way up. And very important are the indications of the expressions of this at the surface. And you can see what to the, let's see if I get this thing working here. This is an actual hydrocarbon seep map of onshore Lebanon. Sorry? Uh-oh. Wrong button. Okay. I'm not hitting that pointer again. Okay, so moving on, we integrate all this information into a stacked model of what's going on. You can see Beirut there and all the different layers that were deposited over time. And that includes understanding what's happening deep in the basement in terms of what the thermal maturation might affect the existence of oil or maybe gas. So back to the actual findings here. So again, I'm going to repeat, the best place to find oil and gas is where you have oil and gas. And we're very fortunate here. There's lots of different areas onshore and offshore, and also in the transition zone. So first of all, let's look at the hyperspectral data. You can see lots of indications not only of direct hydrocarbons seeping up, but also places where the hydrocarbons have seeped up and formed clays. And we can map those, and we have an expression, and those can then be tied to what's going on deeper down. Also extremely important is when we start to build models of what's going on down there, it's very clear to us that the actual source rocks that you have in other areas where there's oil and gas are here. And this is a very important finding. There's no way we can build our models without actually having the reservoir rocks. So you need the source and the place to store it, and we have both. We also find that there's traps and there's the potential of seals, and this is very important too. So both of those seem to be here and in different areas in the onshore. And finally, we take all that information and we look at it together, but we also look for patterns in other areas in the region that have these. And we look for similar patterns here, and we've been scanning through the data. And we found lots of different locations that have the same sort of patterns in terms of rocks, traps, etc. And I'm not going to exactly show you the answers right now because I'm going to wait till Wednesday. But we have lots of different interpretations of where the best hydrocarbons will be onshore and where the potential is. And it looks quite good. So with that, I'm going to leave you for the conclusions on Wednesday, and thank you very much for your time.